Hello everybody, today we're gonna see about the non-parametric model using the superiority function, and the function superiority implemented to the non-parametric method, and it is coined by Lean and Bennis around 1988, which is considered that measure the cultivar general superiority for the cultivar times the environment data. And we will define briefly about the superiority, especially by typing let's ask our RStudio regarding to superiority. So we have to type this one, and also you can get detailed information about superiority. So it's already displayed here. So the term is coined by the Lean and Benz around 1988, and as you see here, there are different arguments. Here is the data, there is the environment, genotype, and response variable, and here also the logical argument, that means the verbose. So by this way we can see the detail, especially the index, that means the superiority index computed for the all and favorable, as well as here for unfavorable environment. So, and it is briefly also there is a formula to do the superiority index, that means usually designated by PI, which is equal to the submissions of J starts from 1. J means it is the location, so tends to N, and there is the X along ID, that means X is represents the yield of the ice cultivar that is grown in the J's location, and also here you can subtract from MG. So here is MG. So MG means it represents the maximum response among the cultivar that is in the J's location. Then you have to square this value, and again let me add bracket over here and divide it by 2n. So n here is represent for what? It is a number of location. If you have 10 location, you will multiply 10 here. So this the PI stands it is the superiority measure of the ice test cultivar that can be defined as the mean square distance between the ice test cultivar and the maximum response. So here is the yield. So here also the maximum response that's obtained from a different location. Maybe it is MJ, maybe it is a control. Otherwise, it will be the maximum yield that is obtained from the locations. So if you get the smallest PI value, we suggest that the overall location it represents as superiority in the sense of what general adaptability. So if you get the superiority index or the PI smallest, so it measures the overall location and it represents superiority in the sense of what the general adaptability of that particular genotype or cultivar. So by this way we can solve, especially when our model is non-parametric, we have to use the superiority function. So as usual, the superiority function is already built in the method package, so we have to call method package and incorporate to our studio. Then if you want to check your structure, also you can type str, and your data name for this tutorial is data GE. So here is the structure of our data. Here is the environment, here is the genotype, and here is the replication. Here also the response variables, that means the grain yield and the hectoliter mass. Even further, if you want to know about detail regarding to your data, so you have to type here question mark, then followed by data and underscore, it is JE. So if you type this one, it will be displayed here. So it is a multi-environment trial and odd, so you will get full information regarding to your data frame. So let's back to our analysis. Then you have to assign any name that you want here, and also you have to use the function superiority, and you have to indicate your data name, then followed by environment, that means the column that contains the environment, then followed the column that contains the genotype, and here also the response variable that that you are going to analyze. So type this one and run into your studio. Yeah, let's print. Then lastly, we will say print and give this name to the parentheses, then run to our studio. Yes, so here is the mean yield, and here also the superiority index for all environment, and this is the rank for all environment. Here is also the superiority index for the favorable environment, the rank for favorable environment, and also here is the PI, it means the superiority index for unfavorable environment, and also is the rank for unfavorable environment. So as I told you before, the smallest the PI value is measured overall location, and it represents the superiority in the sense of general adaptability. So you can select the smallest one. Here is the smallest one, 0.0410 is the smallest, and it's followed by 0.0412, and it's followed by 0.126. So the smallest PI value, that means that the genotype is wider adaptability, so G3 is wider adaptability. And even also you can check simply in order to compare and contrast their number. It's better to use their rank here. So as you see, here is 1, the rank is given 1, that means genotype 3 is widely adapted than that of G8 than that of G2. So you can also simply look the rank. And in similar fashion, you have to do in the similar manner. For example, the superiority index for favorable environment here is again genotype 3 and followed by genotype 8 and followed by genotype 2. When you come to the unfavorable environment, the first one is G8 and here is followed by G3 and also followed by G7. So by this way you can select the favorable and unfavorable as well as for all environment the superiority genotype or cultivar for your data. So thank you for watching, and if you have any question regarding to my tutorial, as usual you can address me through my email wagjiratesfahun at gmail.com, or alternatively you can use YouTube comment box. Thank you for watching. Have a nice time.